This production is brought to you by the University of Edinburgh.
Hello, and welcome to an interactive introduction to MATLAB. This screencast will look at variables and simple arrays such as row vectors and column vectors. Variables are an extremely important concept because they allow us to assign values to symbolic names. For example, x equals 5. The Workspace browser has been mentioned in a previous screencast, and looking at it now, it shows a new variable called x with a value of 5. The Workspace browser holds all the variables we create during a session. For example, I can create another variable called castle and assign it with a value of 12. It now appears in the Workspace browser. Variables don't have to contain values. They can also contain operations on other variables. For example, I can create a new variable called y, which is equal to x times castle. Another method of getting information on variables in the current session is to use the whos command in the command window. This provides very similar information to that in the Workspace browser. It tells us the names of the variables in the session, their size, in this case they're all scalar values, and it also explains how much memory space they occupy and what class of variable they are. Before we move on to look at row and column vectors, I want to talk about two useful commands. The first of those is the clear command. It clears any variables we've created in the current MATLAB session. All variables I entered previously are now gone from the workspace. For example, if I type y, it returns with an error because the variable no longer exists. It is always useful to use the clear command when starting a new problem or exercise. The second command is the CLC command. It clears anything we have previously typed into the command window. It also is useful to issue this command to give you a blank sheet before you start a new exercise. Row vectors and column vectors are commonly used, and the simplest way to create them is to use the square bracket notation to type the elements of the vectors which you want. For example, x might be a row vector containing the elements 1, 2, 3, and 4. The elements are separated by a space to notate that they are part of different columns. In a similar fashion, we can create a column vector y that contains 1, 2, 3, and 4. This time, the elements are separated by semicolons to indicate different rows. We can quite easily use the transpose operator to transpose a row vector to a column vector or vice versa. For example, creating z, which is the transpose of x. The transpose is noted by the single quote. Pressing enter shows z as a column vector. This method of entering the elements of vectors by hand is fine if the vector is simple, but if we wanted to define longer, more complex vectors, it becomes quite tedious. There are a couple of methods to define longer ranges, the first of which is to use the colon notation. I could define a row vector as starting at 1, increasing in increments of 1 until it reaches 10. The first value is where the vector starts, separated with a colon and typing the increments, then another colon, and finally where the vector finishes. It can be seen that MATLAB creates a row vector ranging from 1 to 10 in steps of 1. We can change the step size by using the up arrow to select the previous command and altering the equation to contain a step of 5. This, of course, leads to only two numbers, since after 6 the element would be 11 and therefore greater than 10, and not shown. We can also produce a decreasing vector, such as f, which starts at 10 with a step size of 1 and stops at 5. Before moving on to the second method of producing ranges, we clear the variables and the command window using the clear and CLC commands. A second method of producing these ranges is to use the Linspace function, which stands for linear space. Creating a vector x equal to linspace, starting at 0, increasing to 2 pi, and containing 100 elements. The first number is where the range starts, in this case 0. Then, using a comma to separate the elements, the second number is where the range stops, 2 pi. Separated by another comma, we then input the last number, which is the number of elements in the range, 100. Hitting enter, the command window is then filled with the elements in the range. Using either the colon or the Linspace function are two different options for creating ranges in MATLAB. The final element I want to describe in this screencast is the use of the semicolon after a command. All the commands we have entered so far have been followed by pressing the Enter key. The result of the command has been displayed in the command window, but sometimes we won't be interested in seeing the result because it contains too many elements or it is just one step towards a final goal. To stop the result from being displayed in the command window, the semicolon can be placed after the command. For example, using the clear and CLC commands, and then selecting the previous linspace command using the up arrow, I can add a semicolon to the end. Hitting enter, the results remain hidden.
This production is copyright the University of Edinburgh.